Good day everyone! Welcome to Math Made Easy with Mom Belle. And if you're new to this channel, Lovely Day with Belle, please don't forget to subscribe and click the notification bell for you to be notified to my upcoming videos, okay? Our lesson for today is about division of fractions. In this lesson, you will also learn how to divide fractions using area model. But before we go to the mechanics of dividing fractions, let's talk about some division facts. Division is the opposite of multiplication. Multiplication and division are inverse operation. The word inverse means opposite. Addition and subtraction are also inverse operation. What is a reciprocal? A reciprocal is the inverse or opposite form of a fraction. You find the reciprocal of any number by flipping the numerator and the denominator. Example, 2/5. Flip the numerator and the denominator, and the reciprocal of 2/5 is 5/2. And look what happens when you multiply a fraction by its reciprocal. Okay, we will multiply both the numerators. 2 times 5 equals 10. And then the denominators, 5 times 2 equals 10. 10 over 10 is equal to 1. Okay, the product of any number and its reciprocal is always 1. Let's have example number 1. What is 3 divided by 1/4? We are going to translate this problem as how many 1/4 sections can be created from 3. The problem can easily be solved using area model. Let's draw 3 holes. The fraction for any whole fraction bar is equal to 1. So we have 3 of this whole bar. 1, 2, and 3. And then divide each bar into 4 equal parts. One part of it is 1/4. How many times will the one shaded part of the fraction bar or 1/4 fit into the shaded amount of a whole bar? Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So how many 1/4 are there in 3? We have 12. So we have a total of 12/4. Let's apply solving the problem using the reciprocal and let's see if we can get the same result. So the equation is 3 divided by 1/4. Okay, we're going to divide whole number by a fraction. So how are we going to do that? Change the whole number to improper fraction by adding fraction bar and 1. So 3 becomes 3 over 1. And then change the sign from division to multiplication. And then the reciprocal of 1/4, which is 4 over 1. And then multiply the fractions. 3 times 4 equals 12. And 1 times 1 equals 1. 12 over 1 is equal to 12. Therefore, there are 12/4 in 3. Let's take another example. How many times bigger is the shaded amount for 1/2 than the shaded amount for 1/12? First step, draw a model for 1/2. Always model the dividend first, so our dividend is 1/2. And then second step, draw another model for 1/12. 1/12 is our divisor. And then how many times will the one shaded part of the fraction bar or the 1/12 fit into the shaded amount of a whole bar or in our 1/2? Okay, let's count. 1, 2, 3, 4, 5, 6. So the answer is 6 times. Let's apply solving the problem using the reciprocal and let's see if we can get the same answer. The equation is 1/2 divided by 1/12. So we're going to divide fraction by another fraction. So this time we're going to copy the dividend, 1/2, and then change the sign from division to multiplication. And then take the reciprocal of 1/12, which is 12 over 1. And then let's apply the cross cancellation method. Let's cancel 2 and 12. The common factor is 2. So let's divide 2 divided by 2, 1. 12 divided by 2 is 6. And then let's multiply both the numerators. 1 times 6 equals 6. And then we multiply also the denominators. 1 times 1 equals 1. Or the answer is 6. So I have the same answer. Therefore, there are 6 times bigger the shaded amount for 1/2 than the shaded amount for 1/12. Our next example is how many 3 wholes are in 3/4. Let's draw a model for 3/4 since this is our dividend. There are 3 shaded parts that represents 3/4 and another 2 wholes. 1, 2, 3, and divided each whole into 4 equal parts. How many equal parts do we have? So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 equal parts. This will be our denominator. And how many parts are shaded? We have 3. This will be our numerator. Representing it in a fraction, that is 3/12, or we have 4 groups of 3 and 1 group is shaded. So 1/4. 3/12 or 1/4. Using a reciprocal, our equation would be 3/4 divided by 3 equals. So let's copy the dividend, which is 3/4, and then change the sign from division to multiplication. And then the reciprocal of 3, it's 1/3. And then apply the cross cancellation method. We have 3 and 3. So the common factor is 3. Let's divide 3 divided by 3 equals 1. And then 3 divided by 3 equals 1. And then multiply the numerators. 1 times 1 equals 1. And then the denominators also. 4 times 1 equals 4. Therefore, 3/4 divided by 3 equals 1/4. Let's have example number 4. Solve for n. 5, 6 divided by 2 and 2/3 equals n. Or how many 2 and 2/3 in 5, 6? Okay, let's draw a model for 5, 6 and 2 and 2/3. Then let's divide it by 6 equal parts. So looking at the figure, there are 16 equal parts in 2 and 2/3. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So 16 equal parts in 2 and 2/3. That will be our denominator. And 5 of them are shaded. That will be our numerator. Okay, so 5, 6 divided by 2 and 2/3 equals 5/16. Using the reciprocal, our equation would be 5, 6 divided by 2 and 2/3. Again, let's copy the dividend, which is 5, 6. And then change the sign from division to multiplication. And since our divisor is mixed fraction, let's change them to improper fraction. So 2 and 2/3 becomes 8/3. And the reciprocal of 8/3 is 3/8. And then let's apply the cross cancellation method. We have 6 and 3. Their common factor is 3. So 6 divided by 3 equals 2. 3 divided by 3 equals 1. And then let's multiply the numerators. 5 times 1 equals 5. And then the denominators, 2 times 8 equals 16. Therefore, 5, 6 divided by 2 and 2/3 equals 5/16. What have you learned today? To divide simple fractions, multiply the dividend by the reciprocal or multiplicative inverse of the divisor. Use cancellation if needed. What about if you divide mixed numbers? First, change them to improper fraction, then multiply the dividend by the reciprocal or the multiplicative inverse of the divisor, and then use cancellation if needed. It's practice time! Answer the following equations using cross cancellation method if possible. Okay, I'll give you 5 minutes to finish your work. And timer starts now. Okay class, that's all for today's lesson. I hope you enjoyed the activity. Okay, so see you next time. Have a lovely day everyone.